We have a bunch of people who have a good solution to this formula. Thanks, guys. Hey, guys. It's coming to order. I'd like to hear from someone who can justify, who's willing to justify their answer and talk out loud about it here. Jude seems excited about it. Go ahead.
So sine squared 89 degrees is cosine squared 1 degree.
Wait, I don't think you have everyone's attention. This is beautiful, so I want to make sure everyone hears this.
Sine squared 89 degrees is cosine squared 1 degree. Because they're complementary, so you can just add sine squared 1
Well,
degree.
which identity is that, by the way? We actually gave it a name. I mean, not that one has to give it a name. Yes, it's the cofunction identity, right? The sine of 1 degree is equal to the cosine of 89 degrees, right?
Yeah.
The sine of an angle is the same as the cosine of its complement. Look at the cofunction identities and remember that that's what they say. Okay, continuing.
And so then sine squared 1 plus cosine squared 1 is 1. So you can add 44 of those.
All right, so sine squared of 1 plus cosine squared of 1 is 1. Okay, I'm with you. And there are a bunch more of those.
Right, and there are 44 of those.
Okay.
Right, and then that leaves you only with sine squared 45.
There's still like a loner, a little lonely bear in the middle. Sine squared of 45 is still left over after you pair all the others off. That's a little sad, but okay. And that's, what'd you say that is in the middle? That's, yeah, 1 over root 2 squared, which is a half. Okay, I got you. So we have 1 plus 1, 44 of those, and then a half. So 44.5, is that what you guys got?
Yes.
Good job. A friend of mine, Mr. Smith, came up with this formula. He lives in Scotland. Okay.
Is he Scottish or no?
Yeah.
Is he actually?
Okay, we're gonna save homework questions, even though I know you have them. We're gonna save homework questions for another day here. So the solutions will be on Edline, of course, so you can check them out. But we would like to have enough time to maybe say a few things about 5.3 right now. If it's not obvious already, we're gonna learn some new identities today. Rosie?
Another awesome worksheet.
No, sorry. All right. In fact, I'm giving you on the first 2 slides today. I'm giving you complete permission to not take notes at all. Okay, if you don't want. Okay, and I'm going to turn down the lights just now because I want you to understand that this is going to be like a multimedia presentation. It's like a movie. And you grab some popcorn, sit back and relax. I'm about to derive the cosine difference identity for you. Okay, and at least for me, now you can do whatever you want. I'm going to go probably faster than you can write. So if you like to write it, you can go back and look at the PowerPoint later and write it down. It is. So whatever. I'm the kind of person that I just maybe sometimes like to absorb it. So do whatever you need to do to help you understand this. If you want to sketch some things or write down the general idea, that's fine. But in the end, you're not going to have to rederive this for us at least. Again, we have this idea that we want to give you identities, and we never want to give you one that we haven't justified. Okay, so here goes. Most of them have been really easy to justify. This is the first one that's actually hard to justify. Are you ready? So here's the goal. Today we're going to express the cosine of u minus v in terms of just sine and cosine of u and v. That's the goal. Okay, that's our project right now. And this takes a little bit of work to make this happen. The first thing I'm going to do is I'm going to show you a picture of the angles u and v, because that's a great way to think of u and v as being angles, because we're taking the cosine of them here. So here's a picture of cosine of u in standard position, and I'm going to just choose to put a point on the terminal side of u. How about exactly 1 unit away? Okay. Now that blue point then has the coordinates in terms of u, because it's on the unit circle. Cosine u, sine u. Let's do the same thing for v. There's a picture of v, and its coordinates are similarly cosine v, comma sine v. I haven't lost anyone yet, right? Okay. And now just for fun, let's show you a picture of u minus v. There it is. Did you like that? Do you see it? Okay. For simplicity, for the rest of this proof here, let's let theta be the green angle u minus v. And at the end, we'll just remember that, oh yeah, by theta we meant u minus v. And now I'd like to draw your attention to this purple dashed segment. here's my question. What is the distance between this point and this point? Do you have a way of expressing the distance between 2 points somehow? You have something called the distance formula? That's cool. It just happens to be in your back pocket. Oh, that's cool. All right. Do you remember it? Do you remember how it works?
Yes.
Remember that at all times, the distance formula, if you don't remember the distance formula, it's just the Pythagorean theorem. That's all it is. I hope that was taught to you in that way. So there's the distance formula. It's the square root of the difference of the x's plus squared plus the difference in the y's squared. And if you haven't ever thought about why that's just the Pythagorean theorem, go through and think about it. It'll only take you a second to realize why that's the same as the Pythagorean theorem. Okay, cool. So here, PowerPoint skills. That is that side length in purple. But we also have another way of expressing the length of that purple segment that maybe you didn't first think about. What you're also viewing here in front of you is a triangle. Do you see it? It's not a right triangle, that's true. But I do know some things about this triangle. I do know that the blue and the red sides are of length 1, and I have an angle that I'd like to think about, and it's called angle theta. Could I relate the length of this purple side, the purple dashed side, to the lengths of the other sides and the angle in between, using what? I thought I heard someone say it. What relates these two sides, here and here, to this purple side and the included angle here? Yeah, the law of cosines. So what does the law of cosine say? It says this thing squared, this here, squared, is equal to this thing squared plus this thing squared minus 2 times this thing times the cosine of the angle between them. It's the law of cosine. So it's that right there, right? See if you can figure out why I put the ones in where I did. It's the law of cosines. Do you agree? It's just a little terrible with that big square root dot guy there. Isn't that convenient? We have from the distance formula this big square root thing.
Is this just because we're representing the sides of one?
It happens to be convenient, though it'll all work out if you chose them to be 2. Right? All right. Conveniently, we have this big square root that now goes away. On the right side, I just did a little bit of cleanup on the right side, not much. And then on the left side, I'm actually going to do it here. I'm going to expand those out. Sounds like a terrible idea, but it's actually a great idea. Stare at the expansion for a second. Verify that it's right. Verify that it's right. And also tell me why that was a good idea. Do you see anything? Yeah, what do you see? Cosine squared u.
I see a sine squared u.
Sine squared u.
Here, let's make it really obvious by rearranging some terms on the left side. I've actually done nothing, right? I just rearranged some terms on the left side to make it more obvious. On the right side, I've done nothing. On the left side, I just rearranged some things so that it's obvious that in the parentheses here we have 1, and in the parentheses here we have another 1. Yeah, so 2 total. All right. Again, this entire time, nothing at all has been done on the right side. Right? We're just working with the left-hand side here. I'm going to copy the left-hand side. I'm going to copy this up to here and continue working on it.
You say that the 2 long things are the same as 2 cosine?
Yeah, these are so we're going to subtract 2 on both sides. And then it's irresistible. I'm going to divide by -2. You having your popcorn back there? Nice. Do you actually have popcorn? Oh, impressed. Okay, good. But I like that you have a snack. This is good because it's like a show right now. Okay? So here it is. The show has come to completion. We remember that theta is just u minus v, and this is called the cosine difference formula. And just as like kind of a foreshadow of why this might be useful, can you think about, I don't want to tell you the answer, but can you think about why this would be useful in figuring out, like, oh, I don't know, the cosine of an angle that we haven't ever been able to figure out without a calculator, like the cosine of 15 degrees or something? Don't tell, but think about why this might be a useful thing to, like, yeah. Could you figure out what the cosine of 15 degrees is now? That would be cool. All right. All right, next. So that was like the long multimedia presentation I had in mind that I wanted to share with you, because that proof, unlike almost every other proof we've done so far, is a little bit long, right? Most of the other ones I would expect that you could reproduce if you forgot. But if you forget this on a test or something like that, re-deriving it might be a little problematic, though if you had like a lot of extra time, you could do it probably, right? But it's a little complicated, right? Yeah. No.
Is this going to be on the test?
Bonus points if we rederive.
Nothing today is on the quiz tomorrow. All right, let's keep going.
Why are we learning?
I think you would object to me teaching you something today that would be on the quiz tomorrow. Right? Am I right or am I
I
right?
think it'd be
Okay.
fresher.
All right, are you ready to be lazy mathematicians? Here we go. Let's do the cosine sum formula now. And because we're lazy mathematicians, we'd like to use the previous result, right? Is this a sum? Oh wait, can we make it look like a difference? Let's do that, right? And then let's use the result we just established like less than 60 seconds ago. The cosine of something minus something, we just said, is the cosine of that thing, of the first thing, times the cosine of the second thing, plus the sine of the first thing times the sine of the second thing. Yes? Isn't that what we just said on the previous slide? And then cosine of negative v, that's an interesting animal to me. What is that? Cosine of negative v? That's just cosine v. And sine negative v, that's also an interesting animal to me. What's that? Negative sine v. And we have the cosine sum formula. It's the same formula except with a minus in there. So there they are, the cosine sum and difference identities. A nice slick way that your book all together now in one box. A slick way that some people write this is to write the cosine of u plus or minus v is equal to the cosine of u cosine of v minus plus sine u sine v. Right? So by minus plus we mean whatever you resolve this to be, you resolve this to be the opposite, okay? Right? So the point is it's cosine, cosine, sine, sine. And if what do you put in the middle? Well, you put whatever the opposite was up here, right? So that's maybe an easier way to remember it. All right, next. Are you ready? Of course, we've got to think about the sine sum and difference identities, and I'd like to justify those quickly. All the rest of these come out pretty quickly once we've gotten that big proof out of the way. So let's do the sine. Well, you'll see here. We're going to try and be as lazy as possible again. We know the cosine sum and difference formulas. That's about all I have in my back pocket to help me with this expression. But I think that'll work for me. I'm going to start by re-expressing this as a cosine because I just derived some cosine stuff. So maybe I can use those. And which thing did I use here? Yeah, we talked about this already once today. That's the cofunction identity. And then using the associative law, I've regrouped some things. And now I have the cosine of something plus something, which I like just derived a second ago. Remember what the formula is? It's cosine of this, cosine of that, minus sine this, sine that, right? There it is. And then what's convenient? The cosine of pi over 2 minus u is a cool thing. That's just sine u. And the sine of pi over 2 minus u is just cosine u. And this comes out very nicely. And then see if we can be equally lazy for sine of u plus v. Of course, we're going to use this identity that we just derived moments ago. And try and be as, again, lazy as possible, right? Use odd even. It looks very similar to stuff we've done before. And there are the sine sum and difference formulas now in a box. Yay, they're in a box. And again, you can write those down very quickly too. It's sine, cosine, cosine, sine. And in between, this time the sine is the same. But that's nice to remember. Sine, S-I-N, same S-I-G-N, right? Sine, same. Cosine, not same. I have to think about that one. All right. Can't be the same. There you go. One way or the other, another, we do need these all things that are in a box at the end of the day. In fact, let's put two more things in a box. Wouldn't it be nice to have some tangent, sum and difference identities? I leave. Oh, whoa, wait. I'll hold up for a second. You don't like U and V? I'll consider.
What if you just do like 1 over everything? Can you do the same thing for secant?
Well, as we're doing this, I am about to show you tangent u minus v and tangent of u plus v. How would you, if you're taking the mindset of a lazy mathematician, how would you think you might use previous established results to think about tangent of u minus v or tangent of u plus v?
Sine over cosine.
How about sine over cosine, the things we just derived already, right? Wouldn't that be nice? So I don't actually have the proof for you here, but the thing you just said will work wonders, right? So try and prove these just as a fun exercise later today. Okay? And these will come out in the wash, you'll see. It's fun. Okay? So they're the tangent, sum, and difference formulas. And again, think about how these equip you to do interesting things in life. Like take the tangent of I don't know, like the tangent of 15 degrees. I'll give you a second to copy those.
Yeah, why are you copying? This is God.
No, but that's just the truth.
The questions of the Lord and Savior. He
You
died
have
for
cursed
us.
your grades forever. You will never get the grades.
How do we do this? How do we do this? Cosine is 75 degrees. We're about to do it. We're about to do it without a calculator, too. Doesn't that sound like fun? Yes, it does.
Oh shoot, we actually have to do stuff with this.
How do we get the cosine of 75 degrees? Well, let's take into account the thing we've just been talking about. You're right on time. Perfect. What strikes you? I mean, this is the big, I don't want to give away the first step here, right? Because the rest is just using formulas we use. Can you set us up for success, though, using one of maybe our formulas from that we just talked about? Yeah.
Could you say that it's the cosine of 45 degrees plus 30 degrees?
I like that idea because 45 degrees and 30 degrees, both of those are things I know the cosine and sine of. So I like that idea. So now we just have to remember our formula, right? Cosine, cosine, sine, sine. What is in the middle? It's a minus or a plus? I always forget. Oh, that's right. It's a minus. Sine 45, sine 30. And then everything here you know how to resolve, right? We got root 2 over 2. Or, yeah, or 1 over root 2 is fine. Cosine of 30 is something. Oops, that's 1. Cosine. Oh, I said it right first time. It's good to be fast with your speed trig values, right? So what do we get? Root 6 minus root 2 over 4? Did we do it? I think we did. There it is, the exact value of cosine of 75 degrees without a calculator. Isn't it beautiful? Feast your eyes on that. Root 6 minus root 2 is not root 4. No. Alright, next problem. Figure out what this is. Wait, I don't know the cosine of 73 or the sine of... That's okay, because conveniently, the crazy expression I have is just something.
No. Oh, wait a minute. Wait, this is...
Yeah, look, did you write these down earlier? All your potentials? Which one does this look like?
Oh, it's like the minus 2 thing.
86 degrees.
So like pi over 2.
I can simplify it. I don't know how to
Would you turn it into cosine pi over 2? Or sine pi over 2?
I think it looks like one of the sine formulas. What is it? Sine of... Yeah, it's sine of 73 minus 13 degrees, right? The sine formula is what's in front of us. And then once we figure that out, the game is up, right? That was like the entire content of the problem, basically. Then the sine of 60 is root 3 over 2. So that was fun? Okay.
Oh.
Using the sine difference formula right here. I'll let you stare at that for another second. Is everyone okay with that? Alright. I don't know that anyone will ask you to do that in the dark alley, but there it is. Okay. Like, I mean, that was kind of a contrived problem, but there it was. It's still fun. Prove something. I'm not interested. Alright, no, actually, the proof almost, like, kind of falls out, right? I mean, do it.
Cosine x minus y plus
Are you doing it? Are you doing it?
Oh, we have to do this thing.
This is just an exercise in remembering your identities, right? What do we get? Cosine plus sine plus cosine x, cosine y minus I don't have much to say about that. Let me give you one word of warning and some help for your homework tonight. Especially number 51 tonight. I think it's going to be useful. You're going to see appearing in your homework possibly and in the future a 2x or possibly a 3x. And I think it'll be useful to you to realize that you can split that up. You now know how to even resolve like a cosine of 2x or a sine of 2x, right? Do you see what I'm doing here? So this is a helpful hint for number 51 on your homework in particular. This proof will just like happen immediately for you if you try this. Maybe I should have told you that. It would have been better to like have you struggle, but like this proof is either like painful or really quick. And I was like, thought I'd save you some time. Yeah, I will. So try this. This is not the whole problem. Just a little hint. When you see that, write that. Okay? Don't you agree that that's the same thing? But you might not have thought to do that, so I thought, there you go. I don't know. So, I'm helping you out. I apologize. Robbing you of the joy. I'm going back for a second for the sake of Maddie. All right, have a great.
Remember that tomorrow is the last day of Rockville Holiday Parade. As of today, Mr.
Homework 6 tonight.